Hey everyone, Avinash, thank you so much for joining once again. I'll be giving you a quick primer on building stateful functions with Apache Flink. This will be a 10,000 feet overview of how do you build functions as a service with Apache Flink. With that, let's get started. Before we dive into Flink and functions as a service and durable execution, let's see something that everybody understands. I'm sure we are here at a Streams Meetup, uh, which means everybody here understands how stream processing works, which is you have events coming in uh, from multiple sources and you do either filter, transform, or enrich those events, and then even possibly join those events, and then you finally get a single stream of event or more than one stream of events. So this is a basic fundamental idea behind stream processing, where you either do filter, transforms, or joins. Now, doing this, where you need some sort of framework to do this. So that's where something like Apache Flink helps. Apache Flink is one of the leading open source projects that help you with both batch processing and stream processing. We'll not really talk a lot about Apache Flink itself. Rather, we'll talk about how do you build functions using on top of Apache Flink as a runtime. But the idea behind Apache Flink is it remains the same as any stream processing engine, where you have few processes that allow you to do filters, transforms, enrichments, and then joins. You have and the thing with Flink is you have multiple sources and destinations that it supports. So it's not just Kafka as a source and sink, where you have multiple sources and sinks that Flink support. Now, how do you run functions as a service with Flink? That's what we'll get to today. But before that, let's talk about the problems or some concerns with building functions as a service. Typical functions as a service platform, where if you have multiple such functions, orchestrating them or having a way to actually have communication between them and having so in a consistent fashion, that is a hard problem to solve for, where you have one function talking to another function and you want to be able to coordinate that and make sure that it is consistent. You have retries and you have the state backed up somewhere. All of these are concerns that one might have while building functions as a service. This is where something like Apache Flink helps, where it provides you the runtime to have consistent state and orchestrate the execution of such functions or with one function talking to another. So this was the idea behind having stateful functions. The primary idea behind it is having something reactive like akka workers that can back pressure and allow you to actually execute those functions in a coordinated fashion. At a very high level, Apache Flink stateful functions. It's another open source project under the Apache Foundation. It is built on top of Apache Flink. It is not part of Apache Flink per se, but then it is another open source project that allows you to use Apache Flink as a runtime to run functions as a service and coordinate those functions, orchestrate those functions across multiple executions. Uh, the functions are event driven. What this means is you have multiple event streams that are acting as an ingress to the stateful function runtime. And based on the event, the Flink task manager, which is what is the idea behind the core engine behind the stateful function runtime, which is the task manager will then call the various functions that needs to be executed based on the various steps that would have been defined that have been predefined. And once these functions execute their code, then those events can then be sent to another event stream as an egress. So it doesn't necessarily have to be an event stream. It can be any source or a sink that Flink supports with any Flink connector. But Kafka and Kinesis are first class citizens there. But the idea is you have an event stream that is coming in. Flink then allows you to remotely execute any arbitrary number of functions, coordinate them. That is not just the Flink calling one function. So it can also be the function then calling another function, all coordinated through Flink. Uh, Okay, let's go through each one of them and explain or talk through what that actually means. Here, functions is first-class citizen, which means you can run any kind of function that can be remotely hosted outside Apache, outside the Apache Flink cluster, and the local state is then persisted within Apache Flink. So that way, Apache Flink can act as the database for such functions, since the data that is stored here are events that are generated from either the event source or from the Flink or from the durable function. The uh, the uh, Flink runtime would then act as an event or an event driven database. And here Flink stateful functions allow you to dynamically route to any function that is defined within the runtime. What this means is you can arbitrarily call any function with their logical address. So here there is all functions that are defined that are registered as a function within the Flink stateful function runtime will have a logical address which consists of the type and the ID, uniquely identifying each function instance, so that one function can arbitrarily call another function using just the logical address without the need for service discovery. So there's a concept of logical functions within stateful functions. What this means is for every function, the for every function type and for every each identifier or each ID of such function, you have a unique object that is created within Flink. So this allows you to uniquely identify each function. For example, if we were to consider maybe a person as or a function that processes a person as a function. So for each person, there would be a logical address generated. For example, there's Bob. So there's a logical function that is a logical address that is created for the function of type person, or a function that processes a person for Bob. What this means is you can have any number of such instances created within the Flink runtime, and without with a finite number of resources. So you can all these functions are not necessarily active all the time. When if and when the function is executed and the object is created, and then the function is executed. This allows to scale the functions without having to actually be restricted by the number of resources. Uh, Here, with these functions, there is no need for a database. Uh, Flink here will act as the database for every function execution. The state is backed up to Flink using the regular Flink checkpointing and snapshots. So here, Flink will store the state and orchestrate the functions based on those state. Here, typically with functions execution, you have the functions coordinating amongst themselves, where when let's suppose a request is made to service one, and that performs certain actions on the database, and then the service one calls service two. Now there's no way for service one to know whether service two actually executed the request further, and whether the request failed. Uh, uh, but here in this case, the roles are reversed, where the all of it is driven through the database. Here, the database is the Flink cluster, where you have the function, based on the events that land in the Flink cluster, a function is then executed, and then the resulting results are also stored back in the Flink cluster, thereby the Flink cluster orchestrating those functions and having control over which function executes, and having the ability to retry such functions. So this is the idea behind having a consistent state, where the Flink acts as an event-driven database, or the event store, where and the applications do not necessarily have to store the states themselves. Or when I say applications, it is the functions that do not have to store the state themselves, which makes the functions truly serverless. So you do not really have to care about coupling the state with the functions. And this has a polyglot interface. That is, the functions do not necessarily have to be written with Java. There are SDKs for Python, JavaScript, Go, etc. And it's not really restricted by these languages as well. The Flink stateful function runtime talks to these functions over HTTP or gRPC. If we notice the previous slide here, so the Flink stateful function cluster talks to any of these remote functions over HTTP or gRPC, and these functions can be deployed anywhere. It can be on Kubernetes, or it can be fronted by an API gateway, which is maybe running or which fronts Lambda or any such other functions as a service, or it can be a microservice in itself. So these remote functions do not really can be written in any language, and all it needs is an HTTP or gRPC interface to for the Flink cluster to actually call the function to execute it. Which means the workers can be deployed and independently scaled. Does not really have to tie with the Flink cluster or the state. There's a concept of logical co-location and physical separation, which is what I just mentioned, where the functions, the messages, and the state are have a logical co-location. That is, for a particular message, you have the state always being consistent. So the state is stored based on the key, and the messages are always routed based on the key. But these functions can be physically deployed elsewhere, making it allowing you to physically separate them and decoupling them and allowing you to scale them independently. I'll take a brief pause here to see if there are any questions. Trying to see if there are any questions on the concept of behind Apache Flink stateful functions. Was the concept? If there's any conceptual questions, I'll just pause here for a minute. Yes. Sorry, can you speak up? So the state is still stored within Flink. So the functions in itself are stateless, or rather not exactly stateless, but serverless. You can run them about just about anywhere. But the state is still stored in the Flink cluster. So when you define a function, you need to define what is the state that is needed to be stored or checkpointed and snapshotted. So the functions are still stateful, but then the state is decoupled from the function. Yeah. Okay. Moving on. Let's briefly talk about how do you deploy such setup. So this works on Apache Flink as the runtime, which means you can use an existing Apache Flink cluster, but the stateful functions runtime requires coordination. In a production deployment, you would need a master to coordinate the various stateful functions runtime, where Zookeeper is involved for the leader election and for coordination. There's the state store where the state is actually backed up. It can be S3, HDFS, or any such supporting state, or any such storage that is snapshot that is used for storing the snapshots. There are multiple ingress and egress connectors, which are nothing but Flink connectors. Can be Kafka, Kinesis, or any valid Flink connector. It can be a custom Flink connector that can be written as well for the sources and destination. And the stateful function runtime has a dispatcher, which will then call the respective remote functions based on the definition. So there's a definition that you need to define what are the ingress points, what are the egress points, what are the functions, how do you call them, etc. We'll take a look at it once we go to the demo. I have a quick short demo that I'll show how this all works in practice. And in terms of deploying these functions, there are multiple ways you can deploy these functions. The functions can be remote, that is outside the Flink cluster, where the Flink cluster talks to these functions over HTTP to trigger them, or it can be co-located within the Flink cluster. What this means is typically something like a Kubernetes environment, where you deploy the Flink task manager along with in the same pod you deploy the functions as well. So they communicate over localhost. So they're co-located with the Flink cluster. Or the final way is you embed these functions with the Flink runtime. But you're restricted to only JVM based functions in such cases, since you'll have to run it within the same environment. It will share the same JVM process and runs within the, maybe in the Kubernetes world, it will run within the same container. Okay, let's briefly talk about use case where Reddit uses Flink stateful functions. for real-time policy violation detection. So whenever anybody makes any post on Reddit, either a post or a comment or any content that is posted on Reddit, Reddit has a few rules that it would like to evaluate to see whether the post matches its whether it matches the rule, its policy, and whether the post should actually be removed or it should continue, it should be posted. For that, Reddit uses the Flink stateful functions. Earlier, they used to have a custom implementation where they stored the rules in Zookeeper, and for every record that they came, they used to check with Zookeeper and do the computation themselves. But with stateful functions, they have made it more event-driven, where they have a Kafka source which has all the posts, comments, everything that is posted on Reddit. Each post comes to a Kafka topic, and which is, and then there's a Flink cluster which has the Kafka source, the Flink, and they also have the rules which they would like to evaluate. They've defined it as a Lua file where they write the rules in Lua code, and for every post that is made, they fetch the the rules from either the Git repository or S3. They've piped it up to S3 as well, and then there is the actual functions which execute to see whether the post meets the requirements by executing the Lua code. Uh, there's an interesting article that they've written about how they did the migration, and it talks a bit more in depth. But at a very brief idea, this is one use case where they've used to actually not just do stream processing with Flink, but also evaluate arbitrary code to see based on an event to see if they wanted to perform additional actions. Right. So with that, I'll jump to the demo. I'll quickly walk through, run through a demo that this demo is actually part of the Flink project, or rather, it is in the Apache project. You can find the code in the Flink stateful fun playground, but I've modified it lightly to change the ingress and egress. First, let's take a look at the definition of how do you define what are the ingress points, what are the egress points, what are the functions. So there's a YAML file that you need to define to actually define these various orchestrating rules. So there's a Flink or there's a function that is defined here, which is of type HTTP. So this is the function that will be executed uh, for the ingress and egress events. So for there's an ingress that is defined for Kafka, and there's a target of example slash person. So this is the ID of, or rather the type of the function. So each function that is defined, you need to define a type which has the format namespace slash name, which will be used to identify the function. So which is just nothing but a name for the function. So there's an ingress that is defined that reads from the topic people and has the value of read request, which has it's nothing but it's a simple JSON that has a name within it. But the target for this ingress is this particular function. And this function, if you look at the code, will actually trigger the another stateful function. But the actual function is defined within the module.yaml using this particular definition. And finally, there's also an egress defined, which will write the message to Kafka. If we were to take a look at the code, it looks like any other Python code. So I'm using the Python SDK here. So it looks similar to any other code. There's a function which accepts a few inputs, but primarily you need to define that this is a stateful function by binding it with the name. So this was the name that we used for the ingress as well. We pointed it to example slash person, and the state is defined using value spec. So we're storing one just one entity in the state, the visits. So the function just calculates the number of visits that the user does and increments it based on for every visit that they do. And the state is actually defined using the value spec. There, the um, object is visits and it's of type int. The function has a few parameters that it takes, or a few inputs. One of them is the context, which contains access to the state. and the message, which was actually the message passed to this particular execution of the function. The function does nothing out of the ordinary. It just increments the count if the user has already visits or set it to 1, and sends this message to another function. So this is where you can arbitrarily call any other function that is defined just by using its name and using the logical address. So the logical address is a combination of the type and ID. So here the ID is the request name. So there's a function example slash greeter with the ID for every individual person. There's going to be a logical ID. So the ID is set here with the user's name and the value with the actual request and the type of that value. So the next function, which is the function that the previous function is calling, where it has the type defined. So this is how the previous function was able to call this using this type, along with the identifier to complete the logical ID. And this function also does nothing out of the ordinary. It just calls another internal function to print out a fancy greeting. But finally, once this function completes this execution, it will send it to Kafka using the send egress method. It will send a Kafka egress message, and it defines the type for the egress, which is what was defined in the module.yaml. So there might be multiple egresses. The functions can then choose to send to which egress that they want to send to, what is the topic that they want to send to, the key value, etc. This depends on the various egress. So for Kafka egress, this is the format. For other egresses, if it's a custom egress, then the format would be different. And finally, this whole application exposes a HTTP endpoint for the Flink stateful function to actually call this for execution. Right. If I were to just run this quickly. Okay. Everything's up and running. Now I'll just produce few messages. Okay. Produce the message. So we should see something in the egress topic after it's gone through those two functions. The topic name that we gave was greetings. So it says welcome Bob. So if I keep producing more messages, it should keep incrementing the message based on the number of visits. So it just keeps incrementing based on the number of visits. Or if I were to give a different name, it would obviously create another logical instance for that particular user. Maybe right. So since this is a new user, it is able to track the state for that particular user, because that particular user has a different logical ID. So the state store for that or the state for that particular user is different. Since I'll quickly show that how that is in the code as well. Since we're calling it when we're sending it to this particular function, we're calling it with the target type example greeter and the ID, which is the user's name. So for each individual user, there will be a different logical address for the function that is created, thereby it having its own state store or state in Flink. Okay, that was a quick run through of how stateful functions work and quick demo. Any questions? Yes.
Hello. Yeah.
Yeah.
What's the main advantage of running functions on Flink instead of outside Flink? So is it just scaling, or because I mean, of course, the example you could write is just as a simple consumer with some memory state, but yeah. So why do you take the pain of integrating functions directly?
Right. Typically, when you want to build functions as a service, you need something to orchestrate it. That is, when one service calls another service, you want to be able to know whether that service whether the second service succeeded with its execution and thereby called another service, or the whole saga of uh, in orchestrating multiple functions. You need something to do that. There are multiple ways of doing it. You can either make the function idempotent, so you retry from the start, or you have an external coordinator that does it. One way of doing it is with Flink, because Flink then acts as the event database with while you use Flink for stream processing. You can also use it for uh, running arbitrary code and and also orchestrating them. So it makes sense if you're using Flink and they want to also execute arbitrary code while based on an event. So to build an event-driven function,
Yeah,
makes sense to do.
it's
with
cool,
Flink.
but
Yes,
that's
but there are other tools that can help you do the same thing as well. Well, the only main advantage with Flink is you get to do it based on an event trigger without you having to manually write all of the source and sync, etc. Since it comes with the Flink.
Do you know whether this will be integrated, or maybe those two guys know, into Confluence Link?
I'm
Because so
not
far,
sure if this is available in Confluent yet. I think
I don't think so, but maybe you know of plans. No, let's ask him that. Okay.
okay. If there are no questions, I think we'll wrap this up here. Thank you.